Good morning. Good morning. Good morning.
না হলেও চলবে, ঠিক আছে? পরে আমি ঠিক করে দেবো।
এইটাতে প্রবলেম হচ্ছে। তুই এটাতে স্টার্ট করে দে, পরে যখন দেখ এখানে যদি চলে আসে তাহলে এটা করে দিবি, ঠিক আছে? এই যে আজকে আমার
অন করেছিস?
হ্যাঁ অন করাই আছে।
এটা
বলে দিই, শুনতে পাচ্ছিস? So, so Shubhadeep Chakraborty, yes, good morning. I'm here. So today I start. This is the continuation of eigenvalue and eigenvector. Can you hear me? Please tell me. First of all, tell me. Can you hear me? Sohini, Ankon, Ushoshi, Anushka, Navojit, Sharupo, Unusua, Anirban, Shubhodit, Pritha. Are you hearing me? Good morning, everybody. Please tell me. Please tell me. So can I start? Can I start? Okay. First, I state the Cayley-Hamilton theorem. Statement. Every square matrix satisfies its own characteristic equation. So Cayley-Hamilton theorem states that every square matrix satisfies its own characteristic equation. That means this is a characteristic equation. I is identity matrix. We already know this is a monic polynomial. That means the coefficient of highest degree is 1. Then In is the identity matrix of order n. So we know adjoint of lambda I minus a into lambda I minus a. This gives data of lambda I minus a in. We know this result. Now we write adjoint of this equal to where Cn minus 1, Cn minus 2, C1, C0 are matrices of order n minus 1 cross n minus 1 suitably chosen. Then adjoint of lambda I minus a, lambda I minus a equal to lambda to the power n Cn minus 1 plus lambda n minus 2 Cn minus 2 lambda n C1 C0 into lambda I minus a. This is equal to, sorry, this is lambda n minus 1. So this is equal to lambda n Cn minus 1 plus lambda n minus 1 Cn minus 2 Cn minus 1 a plus n minus 2 Cn minus 3 Cn minus 2a lambda C0 C1a minus C0 a. So we can write this as, so please tell me, can you get this thing or not? Pritha, Suraj, Somer, Anirban, tell me, can you get this or not? Tell me, I am waiting for you. This is equation 1. Now lambda I n, this is equal to lambda n I n. So this is equal to lambda n I n since adjoint of lambda I minus a, lambda I minus a equal to date of lambda I minus a in, then this imply Cn minus 1 equal to in, Cn minus 2 equal to so Neeraj, actually you want elaborate which one? Please tell me. This is line number 1. Count from here. Line number 1, line number 2, line number 3, line number 4, line number 6, line number 7, line number 8. So please tell me which line. Which line you need more elaborations? You need. Please tell me, Neeraj. Equation number 1. This. Okay. So see. Okay, I know. So adjacent of lambda I minus a into lambda I minus a. If you multiply this portion is this one. Okay. So you multiplied this, then you get Cn minus 1, lambda n minus 1, Cn minus 2, lambda. This is just lambda, sorry, this is just lambda. This is just lambda. Lambda square C1 plus lambda C naught minus lambda n minus 1 Cn minus 1 a minus lambda n minus 2 Cn minus 2 a minus lambda C1 a C naught a. Now take a now lambda n, if you take lambda n common from this, and so no lambda n C1, this is now from this, and from this you get lambda n minus 1 Cn minus 2 minus Cn minus 1 a. Agree? Similarly, lambda n minus 2 means here this is lambda n minus 2 Cn minus 2, then lambda n minus 2 Cn minus, sorry, this is Cn minus 3, Cn minus 3, Cn minus 1, Cn minus 2, Cn minus 3, then lambda n minus 2, this term combine, if you combining this term and this term, then you get this, and so on. Clear? Clear, Neeraj? Please check. Please check. Okay, thank you. Do you understand this portion? Adjacent of this adjacent of lambda I minus a, I write this as a sum of n matrices whose order n minus 1 n minus 1. Are you understand this? If you have any doubt, please tell me. I can explain with an example. Take that A is a, suppose A is a 2 cross 1 3, and this is a cofactor. Ai j. This is minus 1 whole to the power I plus j, minor of Aij element. So if you consider all these things, then you can write this adjacent matrix as a sum of n matrices whose order n minus 1 cross n minus 1. You can check via this example. Please check it. It is always possible. Okay. So now okay, Swarnabho, actually, or you can always write the adjacent of lambda I minus a as a sum of n matrices of order n minus 1. Okay, so just take an example. Suppose your A is like that 2 1 2 3 1 1 1 1. Then adjacent of lambda A minus a, you can write A11 A21, which is a, where Aij is a cofactor of ijth element, and you know the formula of a cofactor, that is minus 1 whole to the power I plus j mij is a minor of ijth element. So for example, here A11 means, so A11 means minus 1 whole to the power 1 plus 1 lambda minus 3 minus 1 lambda minus 1. So and so on. So you can easily, after replacing all the values of lambda 1, A11, A21, A31, A12, A22, A32, A13, A23, A33, then you can easily convert this matrix as a sum of three matrices, because I here n is three matrices, linear combination of three matrices, that is lambda 2 C2, lambda C1, lambda naught, sorry, C naught, where this C2, C1, C naught are some matrices of order 2 cross 2. Okay, you check, please check this thing, then you now you can generalize this adjacent of a lambda I minus a is equal to lambda n minus 1 cn minus 1 plus lambda n minus 2 cn minus 2 plus lambda c1 plus c0. Okay, you can always write this thing. So please tell me any doubt about this line and this line. Swarnavo Navojit. Okay, please tell me. Please tell me any problem regarding these two lines. If not, then I continue. So, okay, thank you. Thank you. So, now C n minus 1 equal to in and Cn minus 1, Cn minus 2, Cn minus 1 A equal to an minus 1 in Cn minus 3 Cn minus 2 A equal to an minus 2 in C naught minus C1 A equal to an A1 in and lastly C naught A equal to A naught in. Just comparing both sides because adjacent of lambda a minus a lambda I minus a is nothing but a this equation. Okay, and date of lambda I minus a in is this equation number 2. Just comparing equation 1 and equation 2, then you get this. Okay, so now an plus an minus 1 a2 is square a1 a naught in. So plus now Cn equal to in. Okay, Cn minus 2 equal to an minus 1 in plus Cn minus 1 a. So one thing, uh, now an minus 1, see that an minus 1 is equal to Cn minus 2 minus Cn minus 1 a, an minus 1 in equal to, so I write this as Cn minus 2 Cn minus 1 a an minus 1 plus n minus 2. So this is equal to Cn minus 3 Cn minus 2a n minus 2 and a1 c0 c1a a and this is equal to minus c0 a. Now this term cancel, then this term similarly this, if you write this term then you can easily check that this terms cancel. So ultimately you get an minus cn minus 1 n an, and this is equal to in cn minus 1 an, and from this portion this is 0 matrix into an, so 0, hence satisfied. Clear? So please tell me, can you get this equation? Okay, can you get same solution or not? Okay, Shwani, thank you. Spectral decomposition of a matrix. Statement: let A be a matrix of order n cross n, be a real symmetric matrix, then A equal to P. This is a capital lambda. P capital lambda P prime equal to sum over I from 1 to n lambda I epsilon I curl prime, where capital lambda is a diagonal matrix whose diagonal elements are eigenvalues lambda 1, lambda 2, lambda n, and xi 1 curl, xi 2 curl, xi n curl are orthogonal eigenvectors corresponding to the eigenvalue eigenvalues lambda 1, lambda 2, lambda n. We know A is I curl equal to lambda is I curl for all I from 1 to n. Now this is equal to I denote this matrix. This is orthogonal matrix because eigenvectors are orthogonal. So P is an orthogonal matrix. I denote this matrix which constructed by the orthogonal eigenvectors xi1, xi2, xin. So AP equal to P lambda. Now since P is a orthogonal matrix, then PP prime or P prime P equal to I or P prime equal to P inverse. Therefore, P prime AP equal to P prime. So this is sorry. So post multiplied P prime by P prime both sides we get this. Since P is a orthogonal matrix, then we write A equal to In, and this is nothing but a lambda is I curl prime is I curl I curl prime I from 1 to n. So this is nothing but a and this is A equal to, hence this implies A equal to sum over I from 1 to n lambda ei. So where ei equal to xi curl prime, and now we see that ei is an idempotent matrix. since xi is a orthonormal vector, instead I take a orthonormal instead of orthogonal. I take orthonormal. Okay, orthonormal. So some authors says P is a orthonormal matrix because this is constructed by a collection of orthogonal orthonormal matrix, or otherwise you can say this is the orthogonal eigenvectors with unit length. Okay, otherwise you can say this portion, uh, or orthonormal eigenvector, orthogonal eigenvector with unit length. Okay, so since this is a orthonormal eigenvector or orthogonal eigenvector of unit length, so this portion xi I prime xi I should be 1. So this is equal to xi I prime. Again it is ei. Hence ei is a idempotent matrix. Now rank of ei, since ei is a idempotent matrix, so rank of ei is nothing but a trace of ei, and trace of ei means xi equal prime, and we know trace of ab equal to trace of ba, so xi prime is same as trace of xi prime xi, and this is 1. Hence we can write this statement a can be written as a, since a equal to sum over I from 1 to n lambda ei, where ei is a rank of ei is 1, so we write a as a can be written as a sum of n idempotent matrix with rank 1. Sum of, rather linear combination of, it is better to write linear combination of, because lambda is also involved, linear combination of n idempotent matrix of rank 1. So if, so generally we can say that if A is a, if that is for any real symmetric matrix, instead of A it is better to write any real symmetric matrix, any real symmetric matrix can be written as a, so you write this statement as any real symmetric matrix can be written as a sum of the written as linear combination of n idempotent matrix with rank 1. Clear? With rank 1. Clear? Please tell me. If you have any doubt, please tell me. অনির্বাণ পারমিতা, বিশ্বনাথ, শাশ্বতী, tell me any doubt? Ruchira, please tell me. Can I rub this portion? Okay, Ruchira. Thank you. Singular value decomposition. Now we consider any real matrix A of order m cross n, or the previous result we observed that A is a real matrix but symmetric, that is symmetric matrix always square matrix, but now we consider a rectangular matrix. A is a rectangular matrix. In this case, also we can have spectral decomposition. Note that A prime or A prime A are symmetric matrices. Symmetric matrices. Thus, the roots, positive roots of A prime A or of A prime A prime or A prime A, say lambda r square. Suppose rank of A equal to R, then it has r non-zero eigenvalues, that is lambda 1, lambda 2, lambda r, and you know if eigenvalues of A is lambda 1, lambda 2, lambda r, then eigenvalues of A prime or A prime is lambda 1 square, lambda 2 square, lambda r square, are called singular values of A, where r equal to rank of A prime A or A prime, where r is a minimum of order of a matrix A, m comma n. And here I need to mention that rank of, we consider a real symmetric matrix of order m cross n with rank of A equal to r. So let u1 curl, u2 curl, ur curl be r orthonormal characteristic vector or eigenvector of A prime corresponding to the eigenvalues lambda 1 square, lambda 2 square, lambda r square of A prime. Then using previous result, that is spectral decomposition, we can write U is a matrix which constructed by collection of eigenvalues, eigenvectors u1, u2, ur, lambda square, capital lambda square, and denote this by 1, where u equal to ur and lambda equal to diagonal matrix whose diagonal elements are lambda 1 square, lambda 2 square, lambda r square. Okay. Now from 1 we can write u prime a prime u lambda inverse lambda, that is post multiplying by lambda inverse, which is a diagonal matrix whose element lambda 1, lambda 2, lambda r both sides. Then this gives u prime a v, I denote this matrix by v, equal to capital lambda, where v equal to a prime u capital lambda inverse, and order of a v is n cross r. The order of a v is n cross r. Again, v is written as a is nothing but u is nothing but a u1 curl, u2 curl, ur curl, and lambda inverse, the diagonal matrix whose diagonal elements is lambda 1, lambda 2, lambda r. So this is equal to lambda inverse, so it should be lambda 1 inverse, lambda 2 inverse. Diagonal elements are lambda 1 inverse, lambda 2 inverse, lambda r inverse. Okay, so this is equal to a u1 a prime u1 curl divided by lambda 1 a prime u2 curl divided by lambda 2 a prime ur curl divided by lambda r. This is equal to v1 v2 vr. So where vi curl whose order is n cross 1 is nothing but a prime ui curl by lambda I, where I from 1 to r. So this is a ith column of v. Now check that check vi prime vj curl, this is vj, this is equal to ui prime a prime uj curl by lambda I lambda j. So since lambda 1 square, lambda 2 square, lambda r square are the eigenvalues of a prime, and u1 u2 ur are the eigenvectors of a prime, corresponding eigenvalues lambda 1 lambda 2 lambda 1 square lambda 2 square lambda r square of a prime. So this portion gives ui curl lambda j square uj by lambda I lambda j. So this is equal to lambda, sorry, okay, lambda j by lambda I uj curl, and since ui's are orthonormal vectors, so this should be lambda j by lambda I. If I equal to j, that means this should be 1. If I equal to j, and otherwise 0. This means, this imply v1 curl, v2 curl, vr curl also is a set of R orthonormal vectors. Hence, Vi is actually Vi is orthonormal characteristic vectors of a prime a. Agree? Corresponding to the non-zero eigenvalues lambda 1 square lambda 2 square lambda r square of a prime a. Okay. Now you can easily check this statement. See, we know ui is a eigenvalue, eigenvector of a prime corresponding eigenvalue lambda I square. So this should be this. Okay. Now a prime, you pre-multiply both side by a prime, then you get okay. Now vi equal to vi equal to vi means vi equal to here. From here you get vi equal to vi curl equal to a prime ui curl lambda I. So a prime a prime ui curl a prime ui curl by lambda I equal to lambda I square a prime ui curl lambda I, or a prime a vi curl equal to lambda I square vi curl, where I from 1 to r. Hence this statement. So we can make this statement. Actually VI's are characteristic vector of a prime, and from here we see that Vi is also orthonormal vector. Hence Vi curl is orthonormal characteristic vectors of a prime a corresponding to the non-zero eigenvalues lambda 1 square, lambda 2 square, lambda r square of a prime a. Okay. So we can make this statement. Now define two orthogonal matrices P whose order m cross n and Q whose order n cross n as follows. P equal to This first portion I denote by capital U matrix, and remaining portion I denote by U1 matrix. And Q is equal to V1 curl, V2 curl, VR curl, VR plus 1 curl, Vn curl. So this is the first portion is capital V, and second portion I denoted by capital V1. Okay. Where U R plus 1 curl to UN curl are mutually orthogonal and also orthogonal to to U1 curl, U2 curl, UR curl. Similarly, this means P is a orthogonal matrix. Similarly, VR plus 1 curl to Vn curl are mutually orthogonal and also orthogonal to V1 curl to V are curled. As a result, Q is orthogonal matrix. Now, oh yes, thank you, Shrutika. Yes, this should be aim, not aim. Okay, clear. So now, now P prime AQ equal to U prime U1 prime A V V1. So this equal to U prime A V U prime A V1 U1 prime A V U1 prime A V1, where where U prime A V, this is equal to P is M cross M matrix. Okay, not m cross n. Oh, yes, yes, yes. Okay, no problem. No, it is not an issue. Okay, please carry on. Okay, thank you. U prime A V. So this equal to, this is a diagonal matrix. You can check this thing. I already showed this should be this. And I denote this by capital lambda. And U prime A V1, this is equal to, if you write U as a U1, U2, UR and V1 as a VR plus 1 to Vn, then you get this thing. U1 curl prime A UR plus 1 curl U1 curl prime A Vn curl U2 curl prime A UR plus 1 curl U2 curl prime A UN curl Vn curl, and the last row is UR curl prime A. This should be V, not U. Sorry, this should be V. UR curl prime A V R plus 1 curl UR curl prime A Vn curl. Okay, so this matrix is, and this should be 0, null matrix. Why? Since Vi curl prime A, this is lambda I Vi curl, and Vi curl prime A Ui curl prime, Ui curl prime A equal to lambda I not theta. This is Vi. I already see this, shown this result. Okay, Vi curl prime, so Ui curl prime Vj curl, so this is equal to lambda I Vi curl prime Vj curl, so this is equal to 0. Okay, so this shown in this portion. You can check this. Okay, see that this is a V. You put this value V, then you get this result. Okay, and of course you use you use this P and Q are orthogonal matrix. So in this way you write this matrix as lambda I think not lambda I, this is script lambda, capital lambda 0 0 0. Okay, so therefore A is P capital lambda 0 0 0 Q inverse, because Q is a orthogonal matrix, so Q inverse nothing but a Q prime. Okay, since Q inverse is Q prime because Q is a orthogonal matrix. So so from here I write A equal to P is nothing but a U1. This is capital lambda 0 0 and V is V prime V1 prime. So this nothing but a U capital lambda V prime, and this is equal to I from 1 to R lambda I Ui curl Vi curl prime. So you see that this is the same, almost same thing of the result of the result of spectral decomposition. Instead of Ui, here it is Vi. So again it is written as a sum of R matrices because rank of A equal to R. Moreover, one more thing I want to say here. It is the remark. You should write this remark after spectral decomposition. I forgot this remark. I forgot to mention this remark. If A is a, I assume that A is a real symmetric matrix with full rank. But if A is not full rank but real symmetric matrix, that is, if A is singular with rank singular matrix with rank of A equal to small r, which is less than equal to minimum of, sorry, this is square matrix, it should be less than equal to small n. Small n is the order of A. Then same procedure we write this as A can be written, A is sum of linear combination of R elementary R matrices whose rank 1, R idempotent matrices whose rank 1, while lambda 1 lambda are non-zero eigenvalue corresponding eigenvalue of matrix A. This is AI. So the G inverse, this is nothing but a sum of I from 1 to R lambda I, not lambda I, pi curl prime, where pi is, I already mentioned that the pi is a orthonormal eigenvector corresponding eigenvalue lambda I, non-zero eigenvalue lambda I. um, so is a G inverse of A. So please verify this. This is your homework. Sorry, this is your homework. So please verify this. This is a G inverse of A. So this is the another construction of G inverse. If you know the eigenvectors and eigenvalues, then easily you convert eigenvectors to a orthonormal eigenvectors, and using our orthonormal eigenvectors and eigenvalues you can find G inverse as follow. So this results obtained from spectral decomposition. This is the another method of constructing G inverse. Okay, so we will discuss in next class how to construct G inverse using this method. Okay, so now another remark. Let n equal to n and A is symmetric. The roots of A prime equal to roots of A prime A equal to roots of A square, because A is a symmetric matrix equal to, and it is lambda square, that is lambda square. If lambda square is a root of A square, then lambda is a root of, root means characteristic root or eigenvalue, okay, root of A. So see that Vi equal to, and here Vi curl equal to A prime Ui curl lambda. We already get this thing. Since A is a symmetric matrix, so A prime equal to A Ui curl prime lambda I, and A Ui curl is a eigenvector, orthonormal eigenvector of A corresponding eigenvalue lambda I. So we write lambda I equal to Ui curl by lambda I, so Ui curl. Hence here, if A is a symmetric matrix of order, when symmetric matrix, that means a obvious square matrix, then we see that this Vi curl equal to Ui curl, and hence for this result, so you can write this result. So in generally you write this thing, if A is your, in generally you write this thing A equal to this, okay. In generally you write A equal to sum over I from 1 to r lambda Ui curl Vi curl, where A is a real matrix. If A is a symmetric real matrix, then you write see Vi. If A is a real symmetric matrix, then Vi equal to Ui curl, then you write A is equal to sum over I from 1 to r lambda I Ui curl prime. So this is equal to I from 1 to r lambda I. We denote this by Ei curl. We denote this matrix Ui curl prime by Ei curl. So using this, we get this result. A equal to this. Clear? Okay, so this is nothing but a ordinary spectral decomposition. So singular value decompositions convert to ordinary spectral decomposition when A is a symmetric matrix. Now, can I rub this portion? If you have any doubt up to that, please tell me. Before rubbing this portion, please tell me if you have any doubt. I observe that only 20% observing this class now, presently. Please tell me if you have any doubt up to that portion. Please tell me. Okay, Pritha. Thank you, Pritha. Shohini, thank you. Okay. Jisha, thank you. Urunima. What about Dishari? Shorupo? No, sir. So, statement, let A of order n cross n be a square matrix with characteristic root or eigenvalue lambda 1, lambda 2, lambda n, which are all distinct. Then we can express A as A equal to sum over I from 1 to n lambda I di x I curl y I curl prime. So this result, implication of this result or meaning of this result imply spectral decomposition of a square matrix having all root distincts. Having all roots distincts. mention that I forgot to mention this thing where xi curl and yi curl are suitable vectors and di, of course it is non-zero constant, is suitable, sorry, are suitable constant. Okay, suitable constant, di is a suitable constant. Shubhrojit, di is a suitable constant. Clear? We know that proof. We know that the characteristic vector x1 curl, x2 curl, xn curl of A corresponding to the distinct eigenvalue or characteristic roots. Distinct roots are all independent. That is, these characteristic vectors x1, x2, xn are all independent. Okay. So I denote this, I construct this matrix P whose columns are x1, x2, xn. So of course order of P is n cross n. So since this is xi's are independent vectors, so P is non-singular matrix. Then P inverse AP, P inverse A this is equal to P inverse A x1 curl, A xn curl. So this is equal to lambda in P inverse P script lambda, capital lambda. Where capital lambda, I already defined capital lambda is a diagonal matrix whose diagonal elements are lambda 1, lambda 2, lambda n. So hence this is equal to lambda. So from definition, from the definition of xi curl, we have a xi curl equal to lambda xi curl. Xi curl is also called a right characteristic vectors. Now we know the characteristic vectors. Of A and A prime are equal. You can check this thing. This is very trivial. Let yi curl be a vector such that A prime yi curl equal to lambda I yi curl, where yi curl equal to characteristic vector of A prime corresponding to lambda I. So this yi curl is called left characteristic vector, left characteristic vectors of A corresponding to lambda I. So result, xi curl prime y curl yj curl equal to 0 for all I not equal to j. So that is right characteristic vector and left characteristic vector are orthogonal. So we can prove this thing as axi curl equal to lambda xi curl yj curl prime a xi curl lambda yj curl prime xi curl. We denote this by 1. Similarly, a prime yj curl, and this is true when A is a symmetric matrix. Of course, you state this result as if A is symmetric matrix, then xi curl prime yj curl equal to 0 for all I not equal to j. So xi curl prime ayj curl equal to lambda j xi curl prime yj. This is 2. Since these two are this yj curl prime a xi curl and xi curl prime a yj curl, these two are quadratic form, so these two are equal. So from 1 and 2, we write lambda I lambda j equal to xi curl prime yj curl, because xi curl prime yj equal to yj curl prime xi. This is equal to 0. Since lambda I lambda j are all distinct, because I already assumed this thing here are all distinct. So xi cal xi x1 x2 x n and y1 y2 yn both are orthogonal. That is xi and yj are orthogonal. So next result. So please, if you have any doubt, tell me before going to the next result. Please tell me. I think result 2 this is. So xi curl prime yi curl equal to dic. Have you any problem? Tell me. Thank you, Paramita. It's not equal to 0. Consider x1 curl prime y1 curl y2 curl yn curl. So this is equal to x1 y1 curl, x1 prime y2 curl, x1 curl prime yn curl. So this is equal to d1 0 0 0. So d1 not equal to 0, if d1 not equal to 0, this means x1 curl prime y curl not equal to 0. So x1 curl does not belong into the ortho complement phase. This is y1, sorry. Does not belonging to the ortho complement space. y1 curl, y2 curl, yn curl. And if d1 equal to 0, this implies x1 curl belonging to orthocomplement space of y1, y2, yn. So, which means dimension of orthocomplement space should be 0, because this is the Rn. So if yi's are independent, then dimension of orthocomplement space should be 0, otherwise this should be greater than 1, greater than 0. Okay, so the only possibility, and so since we assume that y1, y2, yn are independent, so dimension of orthocomplement space, this is orthocomplement space, dimension of orthocomplement space should be 0, and hence it is only when, and this implies x1 curl should be null vector, should be null vector. Therefore, we can assume so this is always possible that d1 should be non-zero. Similarly, proceeding in this way, we can show that d2 also non-zero, d3 non-zero, and so on. Hence, P inverse AP, this is equal to script capital lambda. Again, suppose we write Q equal to, these are a consequence of above proof, okay? Yn, these are the characteristic vectors of A prime, then Q inverse A prime Q, then this again a capital lambda. So P prime Q, which is x1 prime, x2 prime, xn prime, y1, y2, yn. So this is equal to d1 0 0 0, d2 0 0 0 0 0. So that is a diagonal matrix whose diagonal elements are d1 d2 dot dot dn. So P prime Q inverse, this is equal to Q inverse P prime inverse, and this implies Q inverse is equal to sorry, P in P prime, you can write this P prime as dq inverse, and d equal to q prime p, while d equal to, and d inverse, this is equal to p prime q inverse whole prime. Therefore, capital A P capital lambda d inverse q prime, so this is equal to, D is a diagonal matrix, this matrix, I denote this D, this is D. Okay, so D equal to P prime Q. So A equal to this Xn diagonal matrix whose diagonal element lambda 1 D1, lambda 1 by D1, second element is lambda 2 by D2, and this is lambda n by Dn, and this is y1 prime, yn prime. So this is equal to sum over lambda I di, I from 1 to n, xi curl, yi curl prime. So this equal to I from 1 to n, lambda I pi curl prime. Okay. So have you any problem? If not, I want to stop today. So next day I will continue eigenvalue, eigenvectors, and discuss some results, and then if time permits, then I will discuss the constructional method of G inverse using spectral decomposition. Okay, Shohini, Anushka. So please check this calculation. I think you can get this. Okay. Thank you. So can I end the stream? If so, please tell me. So if you have any doubt, no problem. You can tell. I will discuss. I have no problem. Can I repeat anything? Okay. Thank you. Thank you, everybody. We will meet 10 p.m. coming Sunday. Till then, thank you.